Now, as we consider working with these number systems, many times measurements are taken and the values that are given are approximate numbers. And with that, we run across these two terms that I want you to be familiar with. The first one is the accuracy of a number. Accuracy refers to the number of significant digits that number has, whereas precision of a number refers to the decimal position of the last significant digit. Now, you might say, well, what's a significant digit? We're going to look at that in just a moment. But they give you a quick little example here where we've got a concrete driveway that's 230 feet long and 4/10 of a foot thick. And here they tell you that 230 is more accurate because it's two significant digits, whereas 0.4 is more precise. It's measured to the tenths place. So with our measurements, what we're going to be working with primarily, so we don't exaggerate precision, is we're going to be using these significant digits here. So that's what we're going to focus on. Okay, so let's move. Okay, so this is our list of rules to follow as far as determining if digits are significant or not. First one is if the digit's not a zero, is significant. Okay. The second one is that zeros appearing anywhere between two non-zero digits, that's significant. Leading zeros, however, are not significant. That's real important. Trailing zeros at the end of the number in a decimal number are significant. And then the last little rule here is trailing zeros in a non-decimal number. Those are ambiguous. So let's look at some examples. Okay. All non-zero numbers are significant. So with this first one, consider these blue blanks as if they were non-zero digits. Okay, so like a number such as 134, if you were asked how many significant digits does that number have, the number of significant digits, well, we're just going to count these. I'm going to abbreviate this a little bit. Number of significant digits in this case is 3 because none of these are zero. Even if you had something like 1,234, we're thinking of the blue blanks as being non-zero numbers, that's going to be 4 significant digits. Even if you had a decimal number like 22.134, no zeros, they're all significant, so that's 5 significant digits. But if we had something like this, 2, and we're going to consider the zeros here for our x's, 2,000. Well, these trailing zeros here are not significant, so this one only has 1 significant digit. Little rule with zeros appearing anywhere between two non-zero digits are significant. So let's look at some examples with that. So if we had a number such as this, and we'll consider our zeros here in this yellow blank, like maybe the number 5,016. That's a zero, and previously we said non-zero digits were significant, which is the 5, 1, and 6, but that's also significant because it's between non-zero digits. So here we've got 4 significant digits. If we had something like 22,302, that's 5 significant digits. All of those are significant. Even if we had a decimal in there, 20 .5028. We've got some non-zero digits, but we also have zeros, but they're in between non-zero digits. So all of them are significant. That's 6. If we had something like this, like 5, 0, 0, 4, 0, then we've got a situation, these 2 zeros here that are in between those non-zero digits, those are significant, but this last one here, the 0, it trails, so that's not significant. So this number, 50,040, has 4 significant digits. Identifying significant digits where the leading zeros are not significant. Okay, so as we look at those, let's look at a couple examples of this. In our first example here, we have something like 0, get my little number working, 0.12, and we're asked how many significant digits is that? Well, this is a leading 0. It's not significant. And this is a decimal number, right? So we have 2 significant digits. If we had something like 0.0034, this is a decimal value. These are all leading zeros. They're not significant. So this one only has 2 significant digits. Suppose we had something like this, another decimal number. So those leading zeros are not significant. But now remember, if we have zeros between non-zero digits, then those are significant. So in this case, we have 4 significant digits. Another situation, if we have trailing zeros in a decimal number. Now notice, this one is not just saying trailing zeros. It's saying trailing zeros in a decimal number. So with this rule, they are significant. So if I had something like 2.00, and I'm asked, how many significant digits is that? 2.00. Well, we might look at that and say, well, those are trailing zeros. They don't count, but they do, because this number could be just read as the number 2. So the zeros aren't necessary, but if I put them down there, that means some kind of measurement was taken or something, and that particular hundredths place was important. So these are significant. So this has 3 significant digits. If I had something like 0.500, how many significant digits is that? Well, the leading digit doesn't count in a decimal, but these trailing zeros do, so that's a 3. Suppose we had 0.02300. Those leading zeros are not significant, but these trailing ones are. So that's 4. And one final example, 0.0020. And in this case, those leading zeros are not significant in this decimal number, but the rest of these zeros are. So that's 4 significant digits. Now, the last little rule was about trailing zeros in a non-decimal number. Okay, so in this case, trailing zeros in a non-decimal number is ambiguous, okay? If it really is significant, what we do, if a trailing zero is significant, we use a bar or a tilde to show that. I typically put a bar over that particular digit. So if I had the number like 5,000, how many significant digits is that? Well, there's only one. The trailing zeros don't count, so it's one significant digit. If we had something like this, 2, 3, 0, 0, 1, 0. So this is not a decimal number, 230,010. These zeros here in between those non-zero digits, those are significant, but this trailing zero is not. So that's 5 significant digits. And then our last example, 1, 0, 2. Here again, the zero sandwiched between non-zero digits is significant, but the trailing zeros are not. So here again, we have 5 significant digits. I hope this has helped.